Masterclass with Leo. So today we're doing introduction to calculus, but we're specifically dealing with differential or differentiation of common functions, right? We're differentiating common functions, right? So now, when you differentiate common functions, there's a basic rule that you need to use. This is grade 12 stuffs, guys. This is just an introduction or a revisit to grade 12 stuffs, right? So now, remember when you had to differentiate something like this. When you had to differentiate something like this. When you're given something like this, they say differentiated. Someone created a rule to say, okay, if I want to differentiate something like this, but I don't want to use the first principle, which is what we did in the previous video, right? In the previous video, we did introduction to, not introduction, but revision of first principle. So now, they say differentiate this, but they don't tell you whether to use first principle or not. It means you don't have to use first principle because they just said differentiate. So there's a rule that you need to use, which says, okay, if I have y is equals to ax to the power n, I want to differentiate this. What will I do? When I differentiate y, it will give me dy over dx. This is what I'll get when I differentiate what? Y. And it will give me what? When I differentiate this, n will multiply a. It means I have what? N a x to the power n subtract 1. Where n can be a constant, can be any number, right? It can be any number. So now, if I were to take this, if I were to differentiate this using this rule, following these steps, it means I was going to say dy over dx, it will give me what? Because in this case, n is represented by the value 2. It means I'll have 2 multiplied by what? By 2, right? X to the power what? 2 subtract 1. Therefore, this will give me what? 4x. 2 minus 1 is 1. So, no need to write it, but there's a 1 there. There's no need to write that 1 there, right? This is the rule that we need to use when we differentiate. This is the rule that you'll see in most of your questions when you differentiate in the next coming questions. Let's get another question. You are given a very simple question. They say, what? Y is equals to what? Is equals to 4x cubed. Right? Y is equals to 4x cubed. They say differentiate. In this case, they say differentiate. What are you going to do when you differentiate? You're just going to make it as simple and say, when I differentiate y, I'll get y over dx. Why do I get y over dx? Because I'm differentiating what? Y in terms of x. I'm differentiating y in terms of x. That is why I have dy over dx, which is equals to. Now, when I differentiate this, coming back to this principle or coming back to this rule, I can say, okay, it means 3 will multiply 4. I'll have 3 multiplied by 4. Then x to the power what? To the power 3. Subtract 1. This will give me what? It will give me 12x to the power 2. As simple as that. As simple as that, guys. As simple as that. Now, let's move to the next principle. Now we are trying to differentiate what? A constant. Now, we are trying to differentiate what? A constant. In this case, we're differentiating common functions. Now, let's differentiate a constant. When you differentiate a constant, what will happen? Differentiation, let's just say differentiation. Okay, differential. This doesn't make sense if I say differentiation. Differential, or the differential of a coefficient of a constant 0. Now we're trying to differentiate. You can just say differentiate a constant 0 or a constant, right? Differentiate a constant. What will happen if you differentiate a constant? What will happen if you differentiate a constant? Now, it is very, very easy. When you differentiate what? They say differentiate y is equals to what? Is equals to 2. Differentiate y is equals to 2. You did this in grade 12, guys. This will give you dy over dx. This is equals to 0. When you differentiate a constant, it will always give you 0. When you differentiate a constant, it will always give you 0. Now, that is what you will have. That is what you will have. Now, there's something very, very important that you are introducing now. There is something very, very important, which is varsity, that you are introducing now. A table, right, of differentiation. A table of differentiation. Know that table as you know yourself. If you know that table, then you have the key to differentiation. This is y or f of x, right? When you differentiate it, what will you get? When you differentiate y or f of x, when you differentiate this, you get y, what? Y dy over dx, or you'll get f prime of x. Right? Now, the first principle that we talked about is differentiating what? Common coefficient. Right? When you differentiate this, when I differentiate this, what will I get? I'll get n what? Or a n x to the power n minus 1. That is what I'll get. Right? Now, let's come to important stuffs. When I differentiate sine of ax, a can be any number. It can be 2, can be 4, can be 6, can be 8, can be any number, right? Can be any constant, a. When I differentiate this, what will I get? When I differentiate this, what will I get? I'll get a cos of what? Of ax. That is what I'll get when I differentiate what? Sine. When I differentiate sine, this is what I'll get. Now, when I differentiate cos, of ax, what will I get? When I differentiate cos of ax, I'll get negative sine or negative a sine of ax. This is what I'll get. Right? Now, when I differentiate e to the power what? Ax. This is something new, guys. But I think you did this and you know this. You did this when you did limits. E goes hand in glove with lim. Right? You did this when you did functions. When you did functions, hyperbolic, and functions, when you did the limits, right? So now, when you differentiate this, what will you get? When you differentiate e to the power ax, what you will get is a e to the power ax. That is what you'll get, right? Now comes ln. When you differentiate what we call ln of ax, when you differentiate ln of ax, what you will get is 1 over x. This is a simple and a straightforward table that you need to know by heart. You need to know this by heart, right? Let's move. Let's take one question. Let's try to get one question. Simpler one. We did this. Okay. Where is it? Okay. Now, let's say you're given a question like this. Know this table like you know yourself. If you know that table, then you have the key. You've got the key to differentiation. Once you know that table, you have the key to differentiation. So now, let's say you are given y of 12 over x to the power 3. They say what? Differentiate this. They say differentiate this. The first thing that you need to do, there are 3 basic rules that you need to know when you differentiate. There are 3 basic rules that you need to know. These are the secrets. These are my secrets. I'm giving them to you. Right? There are 3 basic rules that you need to know. The first sure your denominator is not a variable. What does that mean? Make sure your denominator does not have any alphabet. Make sure your denominator does not have alphabet. Right? This must not be any alphabet. Can be X, can be Z, can be what? Change that. Once you change that, then you are fine. 2. These are my 3 secrets, right? These are my 3 secrets. 2. Make sure, or let's just say, instead of saying make sure, remove all sets before differentiating. What do I mean when I say remove all sets? When I say remove all sets, these guys. Square root, cube root, fourth root, whatever. These ones, remove them before you can deal with differentiation. Right? Last one. This is the last one. Before you can differentiate, try, if possible, try to remove brackets. This is the general one, right? That is the general one. That is what both must say. Before you can do anything, deal with the bracket. That is both must. Okay, now, this one, it's linked with the first rule, right? This one is linked with the first rule. My denominator is a x to the power 3. How do I remove that? It means I'm going to say y is equal to 12x minus 3, right? That is the first thing. Then, when I differentiate dy over dx, this will give me what? Negative 12 or negative 3 multiplied by 12, right? What? X to the power negative 3, negative 1. Then this will give me dy over dx is equal to what? Negative, is it 36? Yes, negative 36, right? Negative 36. But now, check. I got negative 36, right? Then now, when I have negative 36, this will give me x to the power minus 4. What do I do with it? It means I'm going to say dy over dx. This will give me negative 36 over x to the power 4. Why? Because I need to write my answer in what? In a positive exponent. I hope you understand. See you in the next video. Make sure to subscribe, share the content with your friends. Guys, please share the content with your friends. Please, let's try to get this channel to 3,000 subscribers, right? Make sure you enjoy your day. Tango!